Hello all, welcome back. In this part, we'll be learning about security, monitoring and logging, and also cost optimization in ADF. So this is one of the most important part, and also the goal of ADF security is very simple. It doesn't want any secrets or public endpoints within the pipeline, or only required access is granted. Let's say you need access for a particular uh, directory or a particular folder in ADLS Gen 2. So the access will be granted at an object level. So it won't give access to entirely for the database or only for a particular table or something like that. So whatever we require, only that particular access is granted to that pipeline. So let's talk about managed identities, which is one of the um, default um, authentication for ADF. And so every ADF automatically comes with managed identity, and you can see over here. So when you go to settings, and you can find a managed identities over here, and you can see user assigned, and you can simply read like user assigned managed identity also enables Azure to authenticate to cloud service. So this is system assigned, and this is user assigned. You can just add a user. You can have permissions to do it, access the ADF, and here is a sample link service which is linked to ADLS Gen 2, and you can see some of the authentication type: service principal, sorry, SAS, URI, account key, and system assigned managed identity and user assigned managed identity. And you can find the credentials. If you add someone, you can just um, have them over here, but for now we don't have anyone, so you can't see anything over here. So yeah, so managed identity is what allows ADF to securely access ADLS, Gen 2, storage, and SQL, Synapse, keywords, and Databricks. So instead of storing password or keys, ADF simply says, "Here is my identity. Do I have a permission?" And um, Azure AD grants or denies access based on that role-based access control. So the first rule in the ADF security is like always use managed identity whenever possible. Now we have um, role-based role-based. So before, just see like using managed identity, why it's easy. Supports role-based access, and Azure rotates keys automatically, and no secrets stored in link service, or no connection string, or no passwords, or no nothing to worry about. So directly it will be granted based on the user and or the system. You can just simply log in. So now no, role assignments or role based access control. So this is how you tell Azure like what is ADF allowed to do. For example, if ADF needs to write to ADLS, give storage blob data contributor. So if ADF needs read from SQL, give a data reader inside the SQL. So if ADF needs to pull secrets from key vault, give it like get secret permission. So you always follow a minimum access rule. Only give what is needed, never assign an owner or a contributor until required. Let's say in a sample, when you create a sample pipeline, you usually tend to provide complete access because um, so to not worry about the security, you tend to give complete access. But usually in a real world you won't give a complete access. You give like only the contributor, like not even contributor, only mostly like read access, just like read secret. So only until what level of that particular user have. If he is a manager, then he might have a contributor role, and if it is he's just a analyst, so he might have a reader role. So based on that, whatever required for that particular user, you only give that um, permission to him. And now moving on to the key vault integration. So which is most important rule, like secrets should never be stored inside ADF, not in link service, not in parameters, not in JSON. Um, just like you have an .env file in a local Python, where while deploying it, you only deploy the application by not the env. Env is given separately. So what you're trying to do is you're trying to separate the secrets from the actual app so that it won't be exposed. Similar way, keyword help us to manage the entire secrets throughout the throughout Azure. So you can just use store secrets of any like connection string or API keys, anything. So it will be used throughout the Azure, but you can also use it in ADF. So why keyword, like keyword integration is necessary? Like store secrets in Azure keyword, and um, instead of all secrets such as like passwords, you have a one stop. You just need to connect to that, and you have to pull out whatever key you are referring to. And also you have to you need to permissions for that as well. You need to permissions to keyword as well. So ADF access keyword using managed identity, so you get secure key storage, automatic key rotation, no exposure, or fully auditing. Like why keyword? Because it's centralized secret storage, rotation without changing ADF, like access logging and role-based access, and secure and compliant. Now private endpoints. So you will come across this topic where you have to use um, self-hosted integration runtime. You don't directly connect with a public endpoint to your on-prem DB. You connect with your integration runtime connects with your on-prem DB with a private endpoint, but you will connect ADF with integration runtime through a public, but IR will always connect to that on-prem DB in a real-world setup through a private endpoint. For it ensures the data security. So it allows ADF to connect to key vault storage, SQL, Synapse, and Databricks. So whatever I just gave, it's just one of the example. So just to get more a quick idea about what is a private endpoint is. So you can create private endpoints for ADLS storage, SQL, keywords, and Synapse and Databricks, just like I said. So you have to do something with networking, like you have to go to just um, do some tweaks in the networking, and over here public endpoint, private endpoint. So this is where you just set up all that, but usually in a real world you won't be dealing with this networking because it has a dedicated endpoint, and if you mess up the data will be exposed. So just like I said, benefits of private endpoints are no exposure to the public internet, so traffic stays inside the Azure backbone, and mandatory for regulated industries. So ADF itself is a managed service and cannot be placed inside a VNet, but private endpoints allow secure point-to-point communication. Now securing data flows um, and integration runtime. So Azure integration runtime, like two areas needs to be specially protected, which is Azure IR and self-hosted integration IR, just like I said, and also the um, data flows. So coming to Azure IR, so managed, which is managed by Microsoft, and no inbound connection, supports private link. Coming to self-hosted integration runtime, which needs a special care. So runs inside your on-prem network or VM, outbound only connection um, over port 443, and keeps the machine firewalled and restrict local permissions and use multiple nodes for high availability. And coming to data flow, like Mapper and data flows runs on Spark cluster. You can secure this by enabling managed virtual network and enabling data flow debug with VNet. So restriction storage access via like role-based access control using private endpoints. So now coming to monitoring and logging. In ADF, it is much more easier to monitor. So you can monitor based on the pipeline level, trigger level, and CDC and integration runtimes, data flow, and also you for each pipeline you can also monitor at an object level. So as you can see, if you see my previous video, you can see how we can see what is the input given to that activity, what is the output given to that activity, and how the pipeline is running, right? So you always need to know what succeeded and what failed, like how long did it run and how much data was moved, and are we seeing SLAs? So ADF monitor pane inside ADF Studio, you can see this monitor section over here, and here you can see the monitor tab, and it shows like pipeline runs, trigger activities, and all these. So you can also filter by date, name, status, and error type, and you can also, like I said, see activity level logs. And so other than this, you can also integrate this workspace with Azure Log Analytics workspace. So once enabled, like ADF begins writing logs into tables like ADF active run, pipeline run. Likewise, you can use KQL and build a custom dashboards, SLA tracking, historic trends for investigation, and build your own logging system by integrating it with logging analytics. So you also have alerts and action groups which sends alerts whenever some pipeline fail or something like that. So alerts can have like notify via email, SMS, or terms, Slack or webhooks, something like that. So new alert role, you can just have this configure notification. So you can add a notification and a short name and action group name. So you can do pretty much everything ADF, like to send a notification whenever pipeline failed. And next, you have cost optimization. So cost optimization, how you can do is depends on pipeline to pipeline, and ADF is pay as you go. As of now, I'm using a free tier, but usually it comes with a pay as you go. So um, you only pay for what you need actually. So if you design poorly, it becomes more expensive, and vice versa. So ADF pipeline cost model. So ADF charges based on pipeline orchestration, active runs, data movement, and data flow, execution time, and integration runtime usage. So the most expensive components are basically mapping data flows, cross-region data movement, large for each loops, debug mode on Spark cluster. So copy operations with inefficient settings, I mean to say. So when we come with DIU and parallelism, so DIU we always see like 5 DUIs per second and 2 DUIs per second. It's nothing but data integration units. So they represent memory, input, output, bandwidth, and compute. So copy activity automatically scales this DUI, but you manually tune them. You can also manually tune them. So when we go to a copy activity, you can see like you have a parallelism and maximum data integration unit. You can just set it auto, so it just use it automatically upscales and downscales, or you can also do it 32, but it costs a lot. So and some of the cost optimization tips, like keep source and sink in the same region, use binary copy for large data, and enable staging for cross format copies, and use appropriate compression types for Parquet and Avro, use partitioning for parallelism, and avoid unnecessary copies. So for the data flow cluster optimization, we have mapping data flow, use Spark cluster. We haven't covered mapping data flows yet, but we will cover in another playlist also. So this is the most expensive part of ADF. Like cluster cost depends on core component, time clusters stay active, and number of debug sessions and auto scaling behavior. So use Dataflow's debug sparingly and use small cluster types when possible, reduce unnecessary joins, avoid wide transformations early, and use schema projection and partitioning. Cache immediately results only if needed, and consider Databricks for heavy transformation. So um, instead of just relying completely on this, so it is asking us to just Databricks is more flexible and more cost efficient than building over here. So to design a cost efficient pipelines, like use metadata driven pipelines, so which we can have more data and fewer activities. So we can gather more data from the metadata itself and use lookup plus for each carefully, avoid large loops, so avoid nested for each, very expensive. Use delta and parquet formats, lower scan cost, and optimize file size. So like avoiding tens and thousands. We'll be discussing about this in our data bricks playlist, where we might get a lot of small um, Parquet files, and we eventually convert them into larger Parquet files, and we just optimize based on that. So we'll be discussing more briefly over there. So combine small activities into fewer larger ones, and avoid running pipelines too frequently. Use trigger that run only when the data arrives, like event based basically. So this when designed efficiently, we can reduce cost by 50%. So as of now, it is free service right now. So you don't really uh, when you're building on a free version and a simple data sets, you don't really get that how costly it was. But when you deal with actual big data, so then you will understand what why cost is really important, because for one run it could cost hundreds of dollars because the data is going to be in GBs and TBs, so maybe in thousands of dollars as well. That's it for this video, and I thank you for watching. See you in the next one.